Hey, Dave, how are you?
I'm doing great. How about you? How you all
I'm
doing
doing
today?
well. I
Doing
appreciate you
great.
joining us. And
Oh,
look,
glad to be here.
we've already had a lot of database talk with Jeff and his updates today, so we're really excited to hear what you've got. But before we really dive into the new stuff, if you don't mind, can we just get a quick introduction, who you are, what you do around Neptune?
Sure. Yeah. My name is Dave Beckberger. I'm a senior graph architect on the Neptune service team. Been doing software for 20 plus years. Been a little over 2 years now here at AWS. But my background kind of comes from full stack software development. But then I kind of moved into this kind of about 6 or 8 years ago. I moved into this newfangled type of database called graph databases. So kind of since then, since that time, I've worked variety of different things, but kind of really focused around how you can use graphs and graph databases to really solve kind of very complex data problems inside your architecture and inside your data ecosystem.
All right. Well, I appreciate that introduction. So I think it makes sense for us to level set, first of all, because people may not be completely familiar with graph databases. Talk to us about Neptune, talk to us about graph databases and maybe some of the differences on, why you might use a graph database over a traditional, relational database.
Yeah, no, that's great. Amazon Neptune is one of the purpose-built databases here at AWS, and it's really purpose-built it's a type of database known as a graph database. And graph databases are really a type of database that deal with complex relationships, and specifically, things that make graph databases good, or I should say, problems that are good. The good ones do you want to start looking at with graph databases for is the types of problems where the connections or the relationships between your data are as important or more important than necessarily the data themselves. Because of the way that graphs work, graph databases are based on graph theory. So if you've taken like discrete mathematics, you probably have heard about Euler and all of that sort of basis of graph theory. And graph databases sort of take that to the level where those concepts and those constructs are basically handled at the low level database. So, if you want to think about, I like to think about kind of databases as like a spectrum of complexity. So you have, something like a key value store that really handles very simple data from a relationship sort of perspective. There's a key, there's a value, that's basically it. You can start moving on to some column-oriented type databases where really you're dealing with single rows of data at a time, something like key spaces. You have move on to like document DB where you have, data that has relationships, but those relationships kind of only really work within, or really inside kind of one atomic unit, that document that you're working with. Relational databases, the ones that we all kind of are familiar with, they do support the concept and construct of relations across different items, but those, like one of the key differences between like relational that most people are aware of and graph databases is the fact that in a relational database, those relationships between your data are really metadata. So at the time that you actually want to traverse or move across those relationships, it has to be calculated at runtime. So that's what foreign keys represent that. And you're doing those sorts of joins, which are building bigger and bigger tables in memory conceptually. Graph databases, on the other hand, really treat those relationships as first-class citizens. So they're actually stored to disk themselves. So, when you're actually going and saying, I want to move from, who are the friends of this person? It doesn't have to calculate that relationship at runtime. It actually is able to just move across that relationship because it exists physically kind of on disk. That's like some of, when I think about graphs, those are some of the technical sides that I look at and I think about it. But then there's sort of the entire part of, when do you want to use one versus not? That's
Yeah.
another question.
Super interesting. You said friends. So can you talk a little bit about the use cases for graph databases? I know
Yeah.
friends is one of them, but
No, yeah, I mean, like kind of like a canonical use case that you'll usually see when people talk about graphs is like social networks. Who are my friends and who are the friends of my friends? And those sorts of problems are definitely graph problems. It's all about basically the network of connections between people. But something like so that's like one, that's definitely kind of one use case. You can do something like that in a relational database if you wanted to.
mm,
That's a join or two joins. But where graphs really start to play a part is when you have a problem that requires either an unknown number of those joins. So let's say, how are Brian and I connected on LinkedIn? Well, we might be one connection, we might be 50 connections, we might not be connected at all. Those are the sorts of things where, graphs really start to excel. And the kind of use cases we see that people really flock to Neptune for, kind of, there's a wide range of them, but kind of in a broad generalization, we tend to see it in kind of 4 areas. The first being the concept of fraud graphs. You have people, they've purchased things, they've used shipping addresses and credit cards, and being able to kind of build together that web of connections to look for those anomalous behaviors where someone is, maybe committing fraud or working with other people to commit fraud, or using synthetic or fake identities to do some sort of identity theft sort of thing. We have the next kind of bucket we look at is what we call identity graphs. Identity graphs are really about taking, data from a couple of different sources and trying to come up with, this specific person is the same as this person in a different system, and it's the same as this person in another system, because, you may want to be able to get a kind of a holistic view around that, and something like a customer 360. The third one that we've worked with for a long time is the construct of a knowledge graph. And a knowledge graph is really, the process of combining different data silos in together in such a way that you can actually, easily be able to see when you're talking about this data in our sales system, it's this one in our inventory system, it's this one in our procurement system, things of that nature. And probably the newest one that we've that's kind of come up recently in the past couple months is this construct of a security graph, which is really, any sort of good, well-built security system is really going to be built upon a variety of different layers of security, and being able to sort of look at that holistically and see how things are potentially connected across those different layers is kind of one area that we've really sort of, seen a lot of growth in lately. I know I just said a lot of things.
That's super interesting, especially around the fraud detection, because I imagine like you arrange the data in such a way that you don't have to have this high compute capacity to detect things like that, right? Like if you combine the compute with a rational database and it did fraud detection, I'm sure you would have to have compute there to perform the same actions, right?
Well, and especially if you think about like a fraud use case, one of the interesting things you can do there is you start to be able to gain insight around essentially the ability to kind of infer that relationships between people. You might have this person A that has used this credit card and had this shipping address, and person B also used that shipping address but a different credit card, or use that credit card to a different shipping address. Well, if you think about it now, because we have all of those different items connected together, we can probably say, with some sort of, like reasonable certainty that, well, they use the same address or the same credit card. So these two people are probably connected to one another in some way, and infer that there's some sort of like knowledge between people, or a connection between people because of the knowledge that's stored in the connections between them.
So, and if I understand correctly, graph databases in general they're designed to be able to kind of pull this relationship pretty quickly, right? So the speed and transaction is supposed to be higher throughput than your traditional relational database. That's the whole point, right?
I would say it's a couple things. One is the speed of moving from like, because that data exists, it's much faster to move from person A to credit card to person B, because I don't have to calculate those joins at runtime.
Right.
They also kind of excel where you have, if you were thinking about like, I have a transaction graph and it's got addresses and credit cards and phone numbers and emails. If you start to write that as a relational database query, you're going to join lots of different tables and get a really kind of very sparse table that comes back as you're doing it because of different information. With graphs, you write that query, it's basically you can pull back, more complex sets of data because your data doesn't have to be homogeneous across it.
Right.
And then sort of like the third aspect there is, especially when you start doing those queries where it's like, how are Brian and I connected, where there's an unknown level of hops. Way graph databases work, you sort of move from point A in your graph to B to C to D to E. And if you were doing this in something like a relational database, you'd have to write like some sort of recursive function that would basically just build a bigger and bigger and bigger and bigger and bigger and bigger in memory table, which is, where we start to see, at that point, you're not really worried about the and that's what it kind of goes back to. That you're not worried about the entities. At that point, you're really worried about the connections, and those are the sorts of problems that graphs are really great at.
Great. I've got a couple of questions here before we even get to your announcement. People are already excited about some of the Neptune stuff. So I'm actually going to move you up here real quick. But is Cassandra supported?
So Neptune uses it uses our own storage layer behind the covers. We're not built on top of Cassandra or any other databases there. We're using our own kind of storage layer that we've is optimized to kind of handle the cloud sort of architecture. So no, in that case, it's not like some other databases that use Cassandra as the backing story. It has its own purpose built.
Gotcha. And the next question was, how much is real-time data inspected due to this?
I mean that a lot of our customers that we're working with are using this for real-time sorts of data transactional. Like Neptune itself is really optimized to handle this sort of transactional graph use cases where you want to, I want to find Brian in my graph and then find if Dave is within 2 or 3 connections of him, because there's a lot, there's, especially if you want to think about a fraud graph, like how close you are related to somebody that's a known fraudster really does tell you a lot. If you're 200 hops away from any known fraudster, you're probably low risk. If you're within a hop, you're probably high risk. Things like that.
And Hari had one follow-up question. Does it allow for active replication that's currently a challenge for RDS?
So Neptune at its core is kind of a single writer, multiple reader based architecture. So there isn't an active multi-writer functionality built in at this point. We do have some stuff that allow you to replicate across clusters from a read perspective, but not an active writer.
That's awesome. So I know, again, and I'm more of an infrastructure person, but working with database folks, especially in the relational database days, there was a lot of emphasis on them on learning the particular query language for whatever database they were working in. But one of the things I learned about Neptune was that we support a lot of different query languages. You want to talk about that real quick?
Yeah, and that's actually kind of a nice tie into what we're here to kind of announce, or one of the 2 announcements today. Yeah, so Neptune in the graph database space in general right now, there's not a single query language that has SQL sort of is for RDS. There's several different query languages, and at Neptune we support now the 3 most common open source query languages out there. So for a long time, we have supported both. There's two most common data models that you use in graphs. One's called RDF, or the Resource Description Framework, and you probably heard of the semantic web. That's sort of the basis of that, the origin of where that sort of data structure comes from. The other one being the labeled property graph model, which consists of elements, which being nodes or vertices and edges, or connecting them together, and properties associated with them. So you could have a vertex that represents a person that would have a first name and a last name property, something like that. On top of those, we've supported for the RDF data model. There's a W3C standard query language out there called Sparkle. We support that. For the property graph, for the long since its inception, we've supported the Apache Tinkerpop query language. But as of our release just a couple of weeks ago, we also support the OpenCipher query language, which is a very very commonly asked feature request from customers, and it's really a sort of different query language to the way that Gremlin works, and one that we think customers will think, and from our feedback, customers really do enjoy having that ability to use that data. That query language on top of their property graph data. Excuse me.
Very cool.
Yeah.
Yeah, I had a chance to kind of play around with this a little bit earlier, and I don't want to give away any spoilers, but I did notice that you could use this new query language with the clusters already running Gremlin, and I thought it was kind of cool. Can you talk a little bit about that?
Yeah, no, that's actually a great point. Yeah, one of the real key things we wanted to do with this query language is it works on property graph data, which we already had Gremlin that worked on it, and we really made it so those were interoperable. So you can load your data one time and choose whether you want to use property graph data one time. You can choose whether you want to run Gremlin on it or you want to run OpenCipher on it. This is great because they're both query languages have their strengths and weaknesses. and being able to choose the, giving customers the ability to choose the right one to solve their problem. You may write part of your data or part of your queries maybe in OpenCipher because it solves the problem better. Part of it maybe in Gremlin because that solves the problem better. But we really wanted to enable customers to be able to kind of make that choice for themselves. It also helps for customers that are currently in Gremlin and want to try out OpenCipher. I don't have to export all my data and reload it or create a cloned cluster. I can just start trying it out on my dev data today. So we really kind of wanted to make that path very easy for customers to be able to, start using OpenCipher.
No, and I think that's something that we often overlook. Everybody here inside AWS, we kind of take it for granted, but I think it's worth calling out that not only are we on this path of providing the right tool and the right database for the right application, and providing customers with a lot of different options to use the right tool for whatever they're trying to develop. But I think it's super cool that we're also allowing them to use the query language that makes sense for how they're trying to structure their graph database.
Yeah, no, and that's great. And I completely agree. And, I'm very excited to have OpenCipher now as a query language because I think, especially for customers that are coming to graph databases and may not have used them in the past, and where it's all there's a lot of new things they have to learn. The SQL inspired nature of it is, I think, going to be very, it's going to really ease the on-ramp as far as, being able to get up to speed and start seeing things quicker because, most people, or at least, most people, developers, data engineers, data scientists have some familiarity with writing SQL queries. And as we'll see when we kind of go through the demo, OpenCipher is not exactly the same, but it feels very familiar. So, that ability to kind of have that for sort of easy on-ramp for customers or for people that are necessarily a little less, potentially maybe less technically astute as some other, or technically up to speed as some others, being able to allow them to use this as well is really a kind of a key driver that we were looking for.
That's awesome. So is now a good time to dive into the demo?
Yeah, no, this is the perfect time to dive into the demo.
All right, let's bring that up then.
Yeah.
All right.
So what we're going to kind of demo here is, you said, I know you said you're an infrastructure guy, but what we're going to dive into is actually
Don't hold that against me, man. Don't hold that against me.
Well, it's a demo. It's a graph of infrastructure. So this is actually comes from some of the things we've seen in the security graph space, where people basically really want to understand the connections inside their cloud resources. You think about your cloud resources. Want to think about it. It's really all about the connections. You have internet gateways, and those are connected to firewall managers that are connected to VPCs that have EC2 instances inside them that have IAM roles. And you start to think about all of this network of information and how these things are connected and how important those connections are in order to be able to do something. So what we're going to kind of look at here is basically a tool that graphs your AWS resources and allows you to be able to kind of look at them. We'll walk through kind of how to use that graph to look for some insight in your data using OpenCipher, the OpenCipher query language. So kind of, first, just to sort of get started, let's take a look at what does a graph of an AWS account look like. So what this graph was generated with was there's an open source tool that Tableau provides out there called Altimeter. And with that tool, it'll basically, assuming you give it the appropriate permissions, it'll go in and scan your account and generate a graph of how each of the resources in your account are used and how they're connected together. So what we're looking at here is actually, this scan of a specific account that I ran it on. As we can see, we start to see things like here's an EC2 instance. It's connected into a subnet. The subnet's in use by this EC2, inside this VPC. That VPC has different network interfaces. There's a database associated with it. So we can start to see how very quickly this can become a very large network. In this case, this is a very small AWS account. There was not many resources provisioned in this, but you can start to see how even just with this visual, this ability to kind of query these things and look at them visually, you can start to see there's some interesting connections here that you may want to investigate further. Maybe
Yeah,
I want to know why there's this rollover sitting over here on the side that's not connected to stuff.
It feels very much like a CMDB. Like you have a relationship with a CMDB, and you have a relationship from like a server to like a network card. It's kind of feels kind of like that.
It's very similar to that sort of use case. In fact, so how did we get here? How did I get this graph? Is probably a great segue here. So this is the OpenCipher query language that we're looking at here, the part that I've highlighted there. So what you'll see is this is a declarative type of query language. So basically, you, much like SQL, you say, this is what I want you to find. Now return me that data. This is sort of the most basic type of query that you could run here. And what it's saying is match is kind of one of the key clauses here. And that's basically saying, find me something that looks like this pattern. So Cypher is a pattern-based query, a query language, meaning that, when I think about a graph, I'm looking at, nodes or vertices and edges that connect them. Well, with Cypher, you basically are able to specify what you want to find in your graph using ASCII art sort of syntax. So I see something wherever I see something that's got two parentheses, that represents a node. Anything that's got square brackets represents an edge. And you'll see that there are these, this sort of dashed syntax here that represents that. In this case, I want to find a node that has an edge that goes from one node to another node. And then I want to return all of the paths that are created here using that. So that's sort of at a very high level, how OpenCipher works, the OpenCipher query language works. But let's start looking at what you might be able to do with this, because just being able to pull back everything in a database isn't, particularly helpful. So what sort of questions and insights are you able to drive from this sort of graph? Well, let's say, we're looking at resources. What's one of the things that you kind of always want to know about your resources? Are any of my resources insecure? Are people using them, or, are they potentially exposed in ways that you may not want them to be? So, we could start that by just doing start with a simple lookup that's basically saying, do you have any insecure policies in here? Do I have any IAM policies that are either, administrator access policies or contain stars? I mean, we all know that sometimes, things get misconfigured or granted too many permissions. So this is a great way to look at this and see what sort of information you can do. So, yet again, what we're doing here is this is all inside OpenCipher. And, we're saying I want to find me any vertices or nodes that are of type IAM policy. And then where the policy name is administrator access or the policy text contains a star in it. And then I want to return the name of those policies. So this is where you can start to see how you can, the SQL inspired nature of this, with the exception of the match, most of this probably looks really familiar to anybody looking that's used to working with, working inside any relational database. So, we can start there and we can run that. We see that in this case, we get back 2 policies, but, that sort of information isn't really where you start to get the power of graphs and this sort of thing. Now you want to start to see and start to, what we do is called traverse it, which is moving from one point in a graph to another. And we want to kind of start traversing these edges to start seeing what's connected to this. What's using these policies? What's using, what roles are using these policies in this case? And we'll see that, this administrator access policy has a couple of roles associated with it. There's one that's called admin. There's one that's called altimeter. And then there's one called I need admin access. Maybe some developer was, set this up because they were trying to debug something, things like that. No one, I'm sure no one's ever done that before, but, start to see these sorts of things and how they kind of connect together, with other policies. There's also this Open S3 policy that we probably want to take a look at from from an infrastructure perspective. So we can, using that same sort of idea, we can take that, even go out to the next level and start expanding out my graph to, okay, so what are you actually, now that we have roles associated with policies that are insecure, what resources are starting to use those roles? Because that's really what what you really start to want to kind of dig into and look at those sorts of things. So, as we see, we're kind of building out this network of items. And if we look at the way that we're actually writing our queries inside this, we see is we're basically building out a bigger and bigger pattern on top of that same basic, filtering capabilities and returning this. We can take that from there. You can go out, additional layers, things like that. In this case, I think I'm going out six hops, 6 connections, and we start to see, you get a very large breadth of, that graph we're looking at to answer this. But one of the interesting things we can also do with graph query languages specifically is they're really optimized for those sorts of queries where you don't know how far you want to be able to go, whether someone's within 1 connection or 2 connections. This is the sort of our Brian and I connected on LinkedIn sort of idea here. And they have built-in sort of features and functionality to look at variable length connection or variable numbers of connections. So in this case, this query up here, you'll see it starts to get very, very long. There's a lot of these, I'm looking across a lot of these resource link and transient resource link edges repetitively. Well, with a graph query language and OpenCipher specifically, you can actually do what's called variable length pattern matching. So I could be able to take that query above that was probably 6 or 8 lines long, and able to very quickly use this sort of notation in there to do those variable length paths. So in this case, I want to repeatedly go out these sorts of resource link or transient resource link edges from 1 to 6 times and return me back my results. So this is really where graph query languages are optimized to handle those sorts of questions that you would have to answer with recursive sorts of SQL. And in my opinion, I've written some recursive SQL before, but that's a lot easier than being able to do *1.6 is much easier than any recursive function I've ever written in my days, at least.
And I got to imagine it's computationally more efficient, right? Like the resources you're going to be using on the server are going to be much less.
Yeah, because of the fact that the data itself is stored on the system, and you're moving from point A to point B. Whether it really has to do with the branching factor. How many edges you're traversing, not necessarily the depth at that point. Because if I'm going out, there's only one parent-child relationship. I can do. It's very, very quick and efficient to scan through all of those, and you don't get that bigger and bigger table problem that you do with. That in-memory table problem that you do with relational databases. Yeah.
Okay.
So just to kind of continue on here a little bit, we're also able to not just look at specific, at the broad set of resources, but we can also start to narrow our search down using this sort of query language. So I can do things like, I want to find all of those administrator access ones or insecure policies, but I really only care if it's associated with an EC2 instance. I don't necessarily care if that's associated with other, potentially not publicly exposed endpoints. So, I'm able to do that sort of thing and able to run through, see a graph of this a graph of this information, see how it's connected together, and then just kind of, finish this sort of idea off. You can also add additional things like maybe I have something that's got an administrator policy, but it's not connected to the internet, so I'm not as worried about it. So you're able to kind of keep iteratively building on top of this data in order to pull this back. So that's kind of just a little bit about the OpenCipher query language that we've just launched into production a few weeks ago, and graph databases in general, and the types of questions that you may want to be able to answer, may want to use them to answer.
I think this is very super interesting because, just like you said, this is a very complex, hard problem, and it seems like this tool solves it fairly easy to the point where you can just deploy this and just kind of start using it in your own AWS account. This is really amazing.
Yeah, I mean, for this specific tool is actually, there's a blog post on the AWS blogs where we actually talk about specifically how you can run this inside Neptune to sort of, if you want to start getting in and using this sort of tooling today, which actually is kind of a nice segue into sort of the other big announcement we wanted to kind of bring up today, which is that as of now, like Neptune actually offers a free trial offer for this. So if you're new to graph databases, this is the best reason to get started with one today. You can go look at your AWS resources, and you can do it on top of a free on top of a free
Wait.
trial. So
We like free.
Oh, hold on. So you're telling me that you get all this technology and you simplified it, it makes it really easy to solve these hard problems, and then you get to play with it for free?
you get to play with it for free. Yeah, with that free offer for eligible accounts, you basically get 750 hours of kind of our development size T3 instances, 10 million IOs, a gigabyte of storage, a gigabyte of backup and storage. And really those are that's plenty for you to start, doing any of this sort of stuff that you saw me do here today. And with that free trial, it's a fully featured trial. There's no limitations on which query languages you can use or the features that, the native features of Neptune that you can use with that. So you can kind of use this to start building out, to start exploring graph databases and using that to build out kind of, these sorts of graphs. Or if you wanted to try out some of the other sample applications we have for fraud or identity graphs or knowledge graphs, and take a look at kind of how those might be usable or useful in some of the problems that you're working on, working with in your business today.
That's
Very
super
cool.
cool. I know I'm going to take your screen down just real quick, but Daniel had a question. He said it looks interesting. It looks similar to iLog and IBM ODM. I don't know.
I'm not familiar with what iLog is, so. But I mean, the concepts of graphs are not new. They've been around. Some of the earliest databases were object databases, which are basically graph, like where you use a lot of the same fundamentals. So graphs have been around a long time, and graph databases are definitely, while on the newer side, are definitely, the concepts have been around for a long time. So it wouldn't surprise me.
Hari's going in there saying, I understand resource requirements are reduced vastly in this. In what scenarios will it demand a random vertical scaling?
I mean, there's lots of scenarios where you may want to vertically scale data. So Neptune is an instance-based database where you basically have one writer, multiple reader, up to 15 read replicas. Depending on, there's a lot of reasons you may want to vertically scale. If you have a lot of concurrent transactions you want to process on the writer, you may need to vertically scale that writer up and down. On a read replicas on any of our instances, you also, there's a buffer cache where you basically, that data is stored locally in about 2/3 of the memory of any instance is used for buffer cache. So the more data you're able to store in that buffer cache, you're able to, the faster you're able to answer queries. And vertically scaling your instance will help with that sort of scenario as well. You also get, at least with when you're using Neptune, you get essentially 2 times the number of vCPUs for any instance. You have that many concurrent threads you can run. So you may want to scale up an instance if you want to be able to do that, or you may want to scale out instances. That sort of depends on specific type of questions, but there is those sorts of needs to scale, based on throughput or latency sort of requirements.
Gotcha. And I'm assuming there's a treasure trove of information out there from AWS blogs, Neptune product webpage.
Neptune product webpage, AWS blogs. In fact, the what I was demonstrating is one of our best tools. That's a tool we call Neptune Notebooks. And it is essentially a Jupyter hosted or a Jupyter based interface that allows you to query the database. Inside that, it's open source, so you can actually run this either hosted on a SageMaker notebook. We have integration with them, or you have the ability to run this on your own EC2 instance or local machine, as long as you can access Neptune. And inside that notebook, not only do we have these magics that let you visualize your results and write queries, but we also have we probably have about 15 or 20 sample notebooks that kind of walk through specific use cases. Here's how you can use OpenCipher. Here's how you use Gremlin. Here's how you use Sparkle, as well as here's how you would build a fraud graph or an identity graph or a knowledge graph. So full kind of end-to-end samples on what you can, the types of things you can do with Neptune.
That's super cool. Not being a database guy, man, you got me really excited because, again, back in my day, it was like databases were just resource hogs, and we were always looking for bigger and better machines. And I love that we're able to now Again, what I was saying before, pick the right tool for the right application and get better results without just throwing more CPU, more memory. I think this is really cool.
No,
Same here.
same here.
Same here. I'm just so excited till we're, I want this program to end so I can just go ahead and start playing with it. I got a lot of things I need to know.
And now with the free trial offer, you can play with it for free.
That's right.
Oh, I'm
That's
super
right.
excited. All the cool things I'm gonna do. I'm gonna do like 7 degrees of Kevin Bacon. It's gonna be awesome.
So
No,
I'm-
I mean 6 degrees of Kevin Bacon is like kind of another classic graph
It'd be a
problem.
great graph problem, right? Yeah. It'd be a great website to build.
Yeah, it will be.
Punch in your name and have it auto generate.
Yeah, that'd be awesome.
Hey, Dave, I'm waiting for some more questions. Give people some time to ask some questions, but just want to make sure we covered all the bases that you wanted to talk about. Is there anything else we left out before we draw this
No,
to
I
an
think
end?
we kind of covered all the kind of key pieces I want to do. I'm just, I'm really excited that we now support this in production and are really, we had a lot of customers. So I mean, we supported it originally in lab mode since last July, and we've had like hundreds of clusters spun up with it, hundreds of conversations with customers about it. So really glad it's now out in the, production supported level to really help accelerate people's adoptions of Graph.
Yeah. And I mean, I remember we just launched Neptune to begin with, and it was a big deal. I love that we continue to keep iterating and driving more innovation into, honestly, a tool that is just going to become more and more important as people build out applications.
Yeah, I mean, graph databases are super powerful when you have those sorts of relationship questions and connected data questions that just aren't very easy to efficiently answer in other sorts of databases. So I'm really excited that we're being able to kind of drive some of this innovation.
So at the risk of putting you on the spot, I might put you on the spot a little bit, but you've seen a lot of these implementations. I was wondering if there's like one of the craziest or most unique graph implementations you've seen. Like you were like, wow, I can't believe somebody came up with that.
I mean, there's lots of crazy and unique ones out there for sure. I think one I can talk about, because I was actually part of the team that implemented with that, I thought was very interesting and amazingly how complex it was for what you think was very simple was when I was working a previous job, I was the chief architect for a genetic genealogy company. So trying to deal with people's family trees as a graph, very natural to represent them as a graph. But the amount of complexity that you get into very quickly when you start going from the fact that, real people's family trees are very complex, parents and step parents and uncles and aunts and step aunts twice removed and all those sorts of things. And the sorts being able to represent those and move across them efficiently and be able to drive very kind of interesting sorts of insights you can get from data. One I can think of that we were looking at specifically was, it was genetic genealogy. So, you want to test someone's DNA to see if they're related. So you want to figure out if your great grandfather was, how he was related. Well, you can't test their DNA. They're not alive. So you were, because we had this graph structure, we were able to answer questions like, okay, who on my family tree is alive today that I can ask to take a test that would prove that we are connected in these sorts of ways?
Yeah.
Things you just never would think about, that you'd want to be able to answer.
No, that's super cool. And the reason I asked is I just want to try to get some creative juices going with the people who are watching on how they might think about leveraging a graph database if they haven't done it today, and go use that free trial to try to build it out.
Yeah, I think that's super interesting. Matter of fact, I want to hear from you guys, the audience, on how you're using graph databases or what you're going to do with your trial. You can hit me up at I Need Help Brian on Twitter. And we just really want to hear what you're doing with it or what you're planning on doing with it. So,
well, Dave, I really appreciate you being here and giving us an insight into the new things that's coming to Neptune and just the overview of Neptune in general. We've said it before, but it's super cool technology, and we appreciate all the work that you're doing on it.
No, thank you for having me. Couldn't have done this without the rest of the Neptune team either. They, I get to sit up here and talk about it. They did, they were the ones down in the trenches making it all work. So definite shout out to the whole team on getting this out to production.